The world is on the brink of war, and world powers are readying their arsenals for battle. As rivals of the United States continue to advance in terms of technology, the U.S. has also put all hands on deck and unveiled something extremely powerful and unbeatable. With an investment of $800 billion, the United States has taken dominance of the seas and developed the most advanced aircraft carrier in the world. What are the capabilities of these vessels? Is it truly the most powerful in the world? Join us as we unveil the incredible features of the billion-dollar vessel that the U.S. recently revealed, shocking the world. This formidable vessel, the USS Gerald R. Ford, is the first of the Navy's newest Ford-class aircraft carriers. It's been almost 40 years since the Navy introduced a new generation of carriers, and the Ford has made history by being the first. With advanced technology and improvements across various systems compared to older carriers, the Ford is more modern and innovative. It's not just continuing past traditions, it's creating its own future with cutting-edge advancements. The USS Gerald R. Ford began its journey when the keel was laid, marking the official start of construction. In earlier times, ships were built with wooden beams, but for modern giants like the Ford, a strong steel beam set the foundation. Shipbuilders and Navy personnel gathered to witness this important milestone. Years later, the Ford was proudly commissioned into active service, taking its place among the Navy's most powerful vessels. Not long after, the flight deck roared to life when an F/A-18F Super Hornet touched down, marking the ship's first-ever aircraft landing. This aircraft carrier then embarked on an intense period of testing, pushing its systems to the limit. The ship performed exceptionally well during sea trials, crew training, and system activations, proving its readiness for the challenges ahead. But one of the most dramatic moments came when the Ford withstood 3 powerful underwater explosions, demonstrating its ability to continue operating even under extreme combat conditions. With its flight deck certified and air traffic control systems ready, the Ford's crew launched into action, carrying out flight operations with Super Hornets, Hawkeyes, and Seahawks. These exercises tested the ship's capabilities and prepared it for future missions. The ship and its crew have gained invaluable experience and are ready to take on the world with their first full deployment, set to make history. The Gerald R. Ford-class aircraft carriers represent the latest advancements in naval engineering, featuring several key upgrades over previous designs. These carriers are equipped with advanced arresting gear, which ensures safer and more efficient aircraft landings. Automation technology has also reduced the crew size by several hundred compared to the Nimitz class, cutting overall operational costs. The class boasts enhanced defense systems, including the RIM 162 Evolved Sea Sparrow missile and the AN/Spy-3 X-band multifunction radar, paired with the AN/Spy-4S band volume search radar as part of the dual-band radar system. Starting with the John F. Kennedy, the AN/Spy-6 will replace the AN/Spy-4, further enhancing the ship's radar capabilities. Another major leap in technology is the Electromagnetic Aircraft Launch System, or EMALS, replacing traditional steam catapults, and a new A-1B nuclear reactor that significantly boosts power generation. The carriers are also designed with stealth features, making them harder to detect on radar. Capable of carrying up to 90 aircraft, the Ford class can accommodate a variety of planes, including the F/A-18E/F Super Hornet, EA-18G Growler, F-35C Lightning II, and unmanned aerial vehicles, along with helicopters like the SH-60 Seahawk. The island has been moved further away, providing more flight deck space and improving operational efficiency. These carriers are designed for intense, sustained operations, capable of launching 160 sorties per day for over 30 days with the ability to surge to 270 sorties. While this ambitious target has faced some skepticism, operational improvements still make the Ford-class carriers a significant leap forward, delivering enhanced combat capability and reduced lifetime costs compared to their predecessors. Another United States naval vessel that has earned the respect of several nations is the Zumwalt-class destroyer. It consists of 3 guided missile destroyers in the United States Navy. These ships are designed for multiple missions with an emphasis on stealth and land attacks. Their main purpose is to provide naval gunfire support, with secondary roles in surface warfare and anti-aircraft operations. The design came from the DD-21 Land Attack Destroyer program, originally named DDX, and was meant to fulfill a congressional requirement for naval fire support, taking over the roles of battleships. The destroyers are built around two advanced gun systems that have turrets capable of holding 920 rounds, along with special long-range land attack projectile ammunition. However, since LR-LAP production was canceled, the guns became unusable, and the Navy decided to focus the ships on surface warfare instead. Starting in 2023, the Navy plans to remove the AGS and replace them with hypersonic missiles. The Zumwalt-class ships are categorized as destroyers, but they are much larger than any other active destroyers or cruisers in the U.S. Navy. Their unique design aims for a low radar cross-section, which helps them avoid detection. They have a special hull shape that slopes inward above the waterline, reducing radar signals compared to traditional hull designs. These ships feature an integrated electric propulsion system, allowing electricity from turbogenerators to power electric motors, weapons, and other systems, like firefighting and automatic pipe rupture isolation. They are designed to need a smaller crew and to be cheaper to operate than similar warships. The first ship is named Zumwalt after Admiral Elmo Zumwalt and has the hull number DDG-1000. Originally, the plan was to build 32 ships with a research and development budget of $9.6 billion. However, due to rising costs, the number was cut to 24, then to 7. By July 2008, the Navy asked Congress to halt Zumwalt production and instead build more Arleigh Burke destroyers. Ultimately, only 3 Zumwalts were completed, and the construction costs rose to an average of $4.24 billion per ship. This is significantly higher than the cost of a nuclear-powered Virginia-class submarine, which is about $2.6 billion. With development costs now divided among just 3 ships instead of the originally planned 32, the total program cost per ship reached $22.5 billion. This significant increase in costs led to a breach of the Nunn-McCurdy Amendment. A spokesperson for the Naval Sea Systems Command stated that even though the Zumwalt-class destroyer is 40% larger than an Arleigh Burke-class destroyer, its radar cross-section is more like that of a fishing boat. The ship's tumble-home hull and composite deckhouse help minimize radar signals. Overall, the destroyer's angled design makes it 50 times harder to detect on radar than a regular destroyer. The Zumwalt's acoustic signature is similar to that of Los Angeles-class submarines. Water flowing along the sides and cool air drawn in through the MAC help lower its infrared signature. The composite deckhouse holds many of the ship's sensors and electronics. In 2008, Defense News reported that there were issues sealing the composite panels in this area, but Northrop Grumman denied these problems. To improve the ship's visibility in non-combat situations, such as busy shipping channels or bad weather, the Navy is testing the addition of onboard reflectors to enhance radar detection. However, there are questions about the usefulness of the stealth features. The Zumwalt's main role is to provide naval surface fire support, which requires it to operate in crowded near-shore areas where large ships can be easily seen, and any surface ship loses its stealth when it fires guns or missiles. The United States is not the only country that's investing in its vessel, and the USS Gerald Ford is not the only nuclear-powered aircraft carrier that is built for multi-role fighters. Let's journey down to France and explore the capabilities of France's Charles de Gaulle, another nuclear-powered aircraft carrier. In 2001, the Charles de Gaulle took over from its older, conventionally powered predecessor, the Foch, which had served the French Navy for nearly 40 years. The French Navy began looking for a more advanced aircraft carrier in the mid-1970s, leading to the creation of the Charles de Gaulle. The ship's construction started in 1989, and it was launched a few years later. The Charles de Gaulle carrier was launched in May 1994, weighing 42,000 tons, making it the largest warship launched in Western Europe since 1950. Initially named Richelieu in 1986 by President François Mitterrand, it was later renamed Charles de Gaulle by Prime Minister Jacques Chirac a year later. The construction faced several delays due to funding shortages and the economic recession, with work stopping 4 times in the early 1990s. The total cost exceeded 3 billion euros, and the ship was finally commissioned in 2001, 5 years late. In 1999, during sea trials, it was discovered that the Charles de Gaulle needed a longer flight deck to safely operate the A2C Hawkeye. Though the extension cost 5 million francs, it was a tiny fraction of the total budget. On its final trial in 2000, The ship's port propeller broke, forcing a return to Toulon for repairs. The supplier was blamed for poor construction, and soon after, a fire destroyed its archives. Temporary propellers from the Clemenceau were installed, limiting the carrier's speed to 25 knots instead of 27. After 2 years, this vessel returned to sea with the Clemenceau's spare propellers, reaching 25.2 knots during trials. In September 2001, the French press reported slightly high radioactivity levels on board, which turned out to be due to updated safety regulations, not a fault in the ship. Around the same time as the U.S. prepared for Operation Enduring Freedom, French media criticized the lack of military readiness. Former President Valéry Giscard d'Estaing even called the carrier a half-aircraft carrier and urged the construction of a second vessel. To make it better, the Charles de Gaulle began its first major overhaul in September 2007. This 15-month refit included refueling its nuclear power plant, essential after 6 years of service. During that time, the carrier had sailed enough to circle the globe 12 times, spent 900 days at sea, and completed 19,000 catapult launches. New propellers were installed, allowing it to reach 27 knots, replacing the older ones from 2001. Upgrades also included better aircraft maintenance, weapons storage, and enhanced communication systems. Aside from its upgraded features, this ship is famous for its capabilities. The Charles de Gaulle can carry up to 40 aircraft, including Rafale fighter jets, Super Étendard, and E-2C Hawkeye early warning planes. According to Novel Technology, the carrier's main deck features a runway angled at 8.5 degrees and an aircraft launch area. Both are equipped with USN-type C-13 catapults, allowing one aircraft to launch every minute. The runway is 195 meters long, while the deck measures 260 meters by 64 meters. Advanced systems like the Sagem Daedalus laser landing aid and the trap stabilization system keep the ship stable, even in rough seas, allowing smooth aircraft operations. In 2007, the Charles de Gaulle received a major upgrade, including refueling its nuclear power plant and installing new propellers, boosting its speed to 27 knots. The carrier's weapons storage was also improved to handle Rafale F-3 jets, armed with Scalp EG cruise missiles and ASMPA nuclear missiles, making it a powerful force. For defense, the ship is equipped with 2 surface-to-air missile systems to protect against enemy aircraft and missiles. It also has a Sagel launchers, 4 Mistral anti-aircraft and anti-missile systems. Let's move on to an aircraft carrier being developed by the U.S.'s greatest rival, China. The Type 003 carrier is one of a kind. It is expected to differ from China's previous carriers due to several advancements. Instead of using ski jumps to launch aircraft, it plans to use steam turbines and electromagnetic catapults. According to Chinese military expert Song Zhongping, Fujian also has an integrated power system. The exact engines on the Fujian are unknown since the carrier is quite new, and like any new flagship military equipment, not much information has been released about it just yet. The carrier's size is similar to the unfinished 85,000-ton Soviet aircraft carrier, Ulyanovsk, and the 100,000-ton supercarriers of the United States Navy. Initially, it was thought to be around 300 meters long, but later assessments using satellite images suggested it might be 316 meters long, with a flight deck 76 meters wide, and could be close to 100,000 tons in displacement. It is the first Chinese aircraft carrier that would enable aircraft to take off with catapults. It has 3 catapults, 2 on the front deck and 1 towards the back, near the angled landing deck. There are speculations that the carrier might have protective weapons on side platforms under the flight deck, like missile launchers for air defense and systems to deal with close threats. The Fujian is obviously up against the American aircraft carrier with the most AI and automation setup in history. Since China has yet to reveal much information on the systems powering the Fujian carrier, the chances of surpassing the systems on the American carrier, which builds on the successes of its preceding Nimitz-class carriers, another class of American carriers that boast impressive AI and automation, are still unknown. It is known that the Chinese carrier is fitted with the most advanced sensors and processing systems that the nation could provide. It begins with an integrated power system, a massive upgrade over the systems used in preceding Chinese aircraft carriers. The system allows for more efficient power distribution, which increases the performance of the ship's sensors and processing systems. These systems include an active electronically scanned array radar system, or ASA radar system, which provides the Fujian with superior detection and tracking capabilities, enabling it to simultaneously identify and track multiple targets. 4 S-band Dragon-I. Type 346 radars and 4 smaller X-band ASAA radar panels support this system. The Chinese carrier's air wing is expected to advance, with the main aircraft of the air wing anticipated to be the naval version of the Shenyang FC-31, known as the J-35. The J-35 is a 5th-generation fighter designed to rival America's 5th-generation F-35 Lightning II. Another aircraft that might be on the Fujian is the Shan KJ-600, which will serve a similar surveillance role as the E-2D Hawkeye of the U.S. Navy. In addition to these fighters, the Fujian would likely host more fighters, rotary aircraft, and unmanned aerial vehicles. The exact count of these aircraft remains unknown for now. However, the Fujian is an 80,000-ton carrier. The Fujian 003 puts China on a list of only 3 nations to wield electromagnetic launch systems, next to France and the US. An electromagnetic launch system is a massive advancement over steam-powered launch systems and the ski ramps found on the previous Chinese carriers. With an electromagnetic launch system, an aircraft carrier can catapult the widest range of manned and unmanned aircraft in a short distance without causing damage to them. The last on the list of powerful aircraft carriers is the CVX, previously called LPX-2. This vessel is a proposed class of aircraft carriers for the South Korean Navy. Unlike the earlier Dokdo-class ships that focused on amphibious missions, the CVX will be built for operating fixed-wing and rotary-wing aircraft, making it a more traditional aircraft carrier. The project was officially announced and funded in the 2020 to 2024 Midterm Defense Plan in December 2020. This project is part of South Korea's effort to build a blue water navy, which started in 2001. So far, this plan includes ships like the Dokdo-class's amphibious assault ships, Sejong the Great-class destroyers, and Type 214 submarines. The goal is to match the growing naval power of nearby countries like China and Japan. Japan has Hyuga-class's helicopter carriers and Izumo-class's destroyers, while China has aircraft carriers like the Liaoning and Shandong, with a new carrier, Fujian, expected soon. In late 2020, South Korea accelerated the design and acquisition of the CVX aircraft carrier in response to naval expansions in neighboring countries. This move aimed to bring the carrier into service 1 year earlier and required a faster procurement process for the F-35B fighter jets it would carry. As of February 2021, work on the CVX was planned to start in 2022 and be completed by 2030. During the MADEX trade fair in June 2021, the Italian shipbuilding company Fincantieri signed a contract with Daewoo Shipbuilding and Marine Engineering to assist in the design of the CVX, as South Korea sought expertise from an experienced industry partner. Despite these efforts, the administration of President Yoon Suk-yeol, elected in 2022, was skeptical of the CVX project. As a result, the project received no funding in the 2023 and 2024 South Korean defense budgets. While the CVX remains part of the Midterm Defense Blueprint 2024 to 2028, released in December 2023, its future will depend on further research and evaluation. Unlike the earlier Dokdo class, the CVX will not have a well deck for launching amphibious assault craft. Instead, its internal space will be used for storing and maintaining aircraft. The flight deck will have a straight design rather than a ski jump, which is common for other operators of the F-35B jet, except for the U.S. Navy. The CVX will be one of the few aircraft carriers globally to have 2 islands. Babcock International, a defense company from the UK, has been helping with the CVX program and may have influenced the Twin Island design as they led the development of the Royal Navy's Queen Elizabeth-class aircraft carriers. The South Korean government has announced that the sensors and weapons for the CVX will be developed locally. The ship will include a multifunction radar for ballistic missile defense, which will also be used on the next-generation KDDX-class destroyer. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.